In this tutorial, we will create bolt and nut by utilizing part modeling and assembly modeling capabilities of Creo Parametric 2.0. Viewers will be able to watch application of many part modeling tools like Extrude, Revolve, Helical Sweep, Chamfer, Mirror, and section views along with 2D sketching techniques and utilization of assembly mates. Finished model file is also available. Check the video description for details. Create a new part file using the default template and enter the name of the model, bolt. Start a new sketch over right datum plane. Orient the sketching plane parallel to the screen by clicking Sketch View icon. Clear the screen by closing the visibility of datum planes, axis points, spin center, etc. Activate the circle tool and draw a circle along with dimensions as displayed. Exit from the sketching mode and switch to Annotate tab. Activate Show Annotation tool and select the sketch. Applied dimension will be highlighted. Turn on its visibility by placing a check mark in the Show Annotation dialog box. Apply and save the changes. Select the dimension in the model tree and open its property from the context menu. Change its display name to D and apply changes. Switch back to the Model tab and activate Switch Symbol command from the Model Intent plane. This will display names of the dimension in place of values. Re-edit the sketch. Convert this circle into construction geometry. This dimension SD0 or D will now onwards be used as a reference dimension, and almost every new dimension would be relative to this dimension. Activate the Sketcher palette and find this six-sided hexagonal shape. Double-click its icon to insert it in the active sketch. As soon as six-sided hexagonal shape is inserted in the active sketch, the Rotate and Resize tool would be active. Move the sketch towards the intersection point of reference lines and rotate it 90 degrees in an anti-clockwise direction. Add a new dimension on this hexagon by deleting the conflicting SD1 dimension. Fill the dimension values as displayed. The sketch is complete, so exit from the sketching mode. Activate Extrude tool and select the sketch. Change the extrude direction and fill the extrusion depth value. Execute the command. Save the model file. Change the color of the model as per your choice. Create a new sketch over left face of the model. First specify new references with which new sketch will be constructed to. Draw a circle tangent to these reference lines and finish the sketch. Create a new sketch over front datum plane. Take the project of the circle drawn on last sketch. Specify new references and draw the sketch as displayed. Delete the unnecessary lines and apply the dimension as required. Finish the sketch and hide the visibility of sketch 2. Activate the Revolve tool and select the sketch. Now select the x-axis of the coordinate system to define the axis of rotation. Specify Remove Material option and execute the command. Start a new sketch on the right face of the model and take the project of the circle drawn on sketch 2. Delete the projected sketch, but you can see its reference is still present there. That would be used to dimension new circle. Create a circle and add the dimension as displayed. Finish the sketch and activate Extrude tool. Select the sketch and then enter the depth value of the extrude and execute the command. Start a new sketch on this face of the model and draw a circle with the dimensions as displayed. Extrude this sketch with a depth value of 2 inch. Activate Edge Chamfer tool and set the dimension scheme to angle and distance. Fill the values in the input boxes. Select the edge and execute the command. Switch to View tab and activate section along Z direction. Open the file named UNF External Thread Profile. Here you can see a sketch profile is drawn. The pitch of the profile is 1 by 20 inches, which governs all other dimensions by some relations. Copy the sketch present in the file and return to the previous file. Activate the Helical Sweep tool. Now define the sweep profile for the helical sweep. Draw a sketch over right datum plane. Define the new references and draw a center line. Draw a line and length of this line would be length of the thread. Exit the sketch. The tool has not selected the internal center line as axis of revolution. So manually select x-axis of the coordinate system to define the axis of revolution. Activate internal sketcher to create the sweep section or profile. Place a geometric point on the intersection of reference lines and lock it. Now paste the thread profile that was copied earlier and which is still in the Windows clipboard. As soon as you paste the sketch, the Move tool will activate. In the Scale field, fill the value 1 and rotate the profile -90 degree. Move the profile near to the geometry point and click OK. Make some minor correction in the profile because in pasting some constraints have gone missing. Add more constraints and lock the dimensions. Apply some more dimension to move the sketch at the required position and exit from the sketch. Specify the pitch value as displayed. Activate the Remove Material option and execute the command. Suppress the section view. Save the file. If you change the dimension SD0 or D in the sketch 1, the model will change accordingly. Create an axis parallel to the x-axis of the coordinate system. Save and close the file. Start a new part file and give it the name nut. Start a new sketch, override the template. Create a circle and apply the dimensions as displayed. Exit from the sketching mode and switch to Annotate tab. Activate Show Annotation tool and select the sketch. Applied dimension will be highlighted. Turn on its visibility. Open the property of the dimension and change its display name as D. Display the names of the dimension in place of value by activating switch symbol command. Re-edit the sketch. Convert this circle into construction geometry. Activate the sketch palette and place the six-sided hexagonal shape in the sketch. Rotate and resize tool is active, so move the sketch towards the intersection point of the reference lines and rotate it 90 degrees in an anti-clockwise direction. Add new dimension on the hexagon by deleting the conflicting SD1 dimension. Exit the sketch and save the file. Activate Extrude tool and select the sketch profile. Select Extrude both sides of the sketch profile option. Fill the extrusion depth value and execute the command. Change the color of the model as per your choice. Create a new sketch over this face of the model. Specify new references and draw a circle tangent to it. Draw a line and exit from the sketching mode. Create a new sketch over front datum plane. Take the project of the sketch drawn previously. Add one more reference and draw more lines. Apply the dimension and exit the sketch. Activate Revolve tool and select the sketch. Define the axis of rotation by selecting x-axis of the coordinate system. Select Remove Material option and execute the command. Select Revolve feature in the model tree and activate Mirror tool. Define the right datum plane as mirroring plane and execute the command. Activate Hole tool and define the placement face. Set the offset references for the hole. Activate Standard Hole option and define the parameters of the hole. Execute the command. Activate Chamfer tool and set the dimension scheme to angle and distance. Select the edge and execute the command. Activate section along Z direction. Open the file name UNF internal thread profile. Here you can see a sketch profile is drawn. The pitch of the profile is 1 by 20 inches, which governs all the other dimensions by some relations. Copy the sketch present in the file and return to the previous file. Activate Helical Sweep tool. Now define the sweep profile for the helical sweep. Draw a sketch over right datum plane. Define the new references and draw a line over it. Add a center line in the sketch and exit from the sketching mode. Specify the pitch values as displayed. Activate internal sketcher to create the sweep section or profile. Place a geometric point on the intersection of the reference lines and lock it. Now paste the thread profile that was copied earlier and which is still in the Windows clipboard. As soon as you paste the sketch, the Move tool will active. In the Scale field, fill the value 1 and rotate the profile 90 degrees. Move the profile near to the geometric point and click OK. Lock dimensions and apply some constraint to move the sketch at the required position. Convert some lines into construction geometry. Add a line to close the open sketch profile and exit from the sketch. Activate the Remove Material option and execute the command. Suppress the section view. Create an axis parallel to the x-axis of the coordinate system. Save the file and close it. Create a new assembly file with the name bolt and nut. Place the bolt part in the assembly. Set the assembly constraint type to default. Click the green check mark to complete the placement of the part. Place the nut part in the assembly. Set the selection type to axis. Select the axis of bolt and nut. A coincident constraint will be applied automatically. Change the selection type to all. Drag the nut part away and select the face of the bolt and nut. A distance assembly constraint would be applied. Change the constraint type to coincident. Now part is fully constrained. Click the green check mark to complete the placement of the part. Save the file.